What if everything you thought about space, atoms, and the universe expanding was wrong? It's a wild thought, right? Some people claim that atoms push each other apart, that space isn't really expanding, and that the concept of spacetime is just a bunch of hocus pocus. But let's dive into this and see what science really tells us. First, let's talk about atoms. They're the building blocks of everything around us. You might think of them as tiny solid balls, but in reality, they're mostly empty space. The nucleus, made up of protons and neutrons, is surrounded by a cloud of electrons. These electrons exist in a probabilistic state, meaning they're not just sitting in fixed orbits, they're more like a fuzzy cloud of potential. Now, when we say atoms push each other apart, we're referring to the electromagnetic force. Electrons repel each other due to their negative charge, creating a sort of invisible barrier. This is why you can't walk through a wall. The atoms in your body are repelling the atoms in the wall. Now, let's shift gears and talk about space itself. The idea that space is expanding comes from observations of distant galaxies. Edwin Hubble discovered that galaxies are moving away from us, and the farther they are, the faster they're receding. This led to the conclusion that the universe is expanding. But some skeptics argue that this expansion might not be what it seems. They suggest that instead of space stretching, the light from these galaxies is simply redshifted due to the Doppler effect. However, the overwhelming evidence from cosmic microwave background radiation and the distribution of galaxies supports the idea of an expanding universe. And what about space-time? This concept, introduced by Einstein, combines space and time into a single four-dimensional continuum. It's not just a fancy term, it's a framework that helps us understand gravity and the behavior of objects in motion. When massive objects like stars and planets warp space-time, they create gravitational fields that affect the paths of other objects. This isn't just theoretical, it's been confirmed through experiments, like the bending of light around massive objects, known as gravitational lensing. So, what does all this mean? It means that while it's healthy to question established ideas, we must also rely on empirical evidence and scientific consensus. The universe is a complex and wondrous place, and our understanding of it is constantly evolving. Theories may change, but the pursuit of knowledge remains a guiding principle. In the end, curiosity drives us to explore these concepts further. Whether it's the tiniest particles or the vastness of the cosmos, every question leads us to deeper insights. So, let's keep asking, keep exploring, and embrace the mysteries of the universe with open minds. After all, science is not just about finding answers, it's about the journey of discovery itself.